I first want to thank Oliver for the invitation to participate in the book. It was amazing for me as a early career researcher. I want to thank also Joseph, Jean-Jacques, and Michel for organizing these 2 days. You're actually giving me the opportunity to come back where it all started, since the chapter in the handbook is a follow-up of my dissertation that I defended in his building in 2017. So my PhD was about Vladimir Fock and his role in the debates over the interpretation of quantum mechanics in the Soviet Union was so central that it was by studying his trajectory that I became aware of most of the episodes of the Soviet history of quantum interpretations. And this helped me to prepare a chapter that was intended to be a general view on the foundation of quantum theory in the Soviet Union. So it is a chapter that elaborates on 7 points, but I obviously do not have time to enter into details of all these 7 points. So to celebrate my return to Paris Diderot, I decided to focus a bit more on Fock and to elaborate a bit around Fock on more general things about the Soviet context. So I will in fact develop consideration from 4 different episodes. So Fock's collaboration with Pascal Jordan on quantum field measurement in 1930, Fock's translation of the so-called nuclear paradox papers, Fock's dispute with Dmitry Lokhintsev in 1952, and finally Fock's well-known visit to Copenhagen in 1957. So let's start with the collaboration with Jordan. The paper they published in 1930 was one of the first to propose new uncertainty relations for quantum field measurement. It was certainly not Fock's most important contribution to quantum field theory. He remains better known for the Fock space, for his collaboration with Dirac and Podolsky on second quantizations. And actually the relations they found with Jordan were quickly disproved. But it is not the main point here. What is of interest is the general context that led them to prepare this paper. So in 1930, Fock was working on the development of a corpuscular analog of the Heisenberg polyquantum electrodynamics. And this had led him to start a collaboration with another Soviet, Lev Landau, and with Rudolf Peirce, that he met during a conference in Odessa. Uncertainty relations were not on their initial agenda, and Fock actually developed them separately with Jordan during a meeting in Kharkiv. The result that proposed Jordan and Fock actually triggered a complete change of direction in the work of the collaboration with Landau and Peirce. Actually, Fock left the collaboration. He was working in Leningrad, and the 2 others were in Zurich. And Landau and Peirce together decided to publish their paper, but asserted the impossibility of making quantum field measurements. So it led to the famous dispute between Landau and Bohr, which is illustrated here by the drawing by Gam. So I was hoping Thiago to maybe introduce it a bit more. Unfortunately not, but I will still skip it. I will say a few words about later developments in the Soviet Union. Later developments on measurement and uncertainty relations, which became creative topics in the Soviet Union. So most notably, we had in 1936 the attempt to quantize gravitational waves by Mayer Bronstein, which included an analysis of field measurability. It revealed an essential difference with the results obtained in quantum electrodynamics and predicted a profound modification of our classical notions of time and space. After the war, we have also Igor Tamm and Leonid Mandelstam, who proposed the time-energy uncertainty relation that was based on the correlation between energy dispersion and time variation of dynamical variables. Those relations are still widely discussed nowadays as an alternative to the traditional Bohr-Heisenberg relations. Fock and one of his students, Nikolai Krylov, immediately opposed the view of Mandelstam, and notably they oppose its statistical significance, only statistical significance. And also in the 60s, Fock criticized the proposal by Aharonov and Bohm for precise measurement of energy in an arbitrarily short time interval. So from all of this, we can already draw some first conclusion on the first steps of Soviet quantum theory. First, a few brilliant Soviet theorists became the privileged witnesses and even the actors of the early developments of quantum mechanics. So to the names of Fock and Landau, we can add those of Tam and Yakov Frenkel. And together they were later known as the Russian branch of the Copenhagen school. So orthodoxy for the moment. Their contribution opened a golden age of Soviet theoretical physics. The episode of quantum field measurement showed that how they were fully integrated into the positive dynamics of world science. Also, the member of the Russian branch of the Copenhagen school brought back in the Soviet Union the modernity of the new practices, as illustrated by the work of Bernstein, who was a close collaborator of all these members of the Russian branch of the Copenhagen school. Nevertheless, through the various developments I quickly mentioned, one can also see that the label Russian branch would be wrongly considered as a form of subordination. So no more orthodoxy. Like Landau, who never really accepted the answer of Bohr and Rosenfeld, or Tam with his work with Mandelstam, the Soviet physicists, although they recognized the heritage that they had received in Western Europe, they cultivated a strong sense of independence. And this contributed to the development of alternative points of view concerning the interpretation of quantum mechanics. So to introduce them, let's rely on Fock's translation of the EPR papers. So Fock translated in 1936 both the original article by Einstein, Podolsky, and Rosen and the answer by Bohr. And at that time, he had developed a sincere interest in the interpretation of quantum mechanics, notably after they discussed complementarity directly with Bohr during a visit of Bohr in the Soviet Union in 1944. So I think, I don't remember who said that you had to discuss complementarity with Bohr before to accept it. It was the case with Fock, definitely. And his translation of the Pierre papers was accompanied by a lengthy comment which supported Bohr's point of view. Fock later wrote substantially on the interpretation of quantum mechanics and developed what Max Jemmer characterized as one of the most trenchant and acclamatory formulation of Bohr's relational version of complementarity. So to briefly summarize, Fock interpreted the wave function as a catalog of potential interactions, and he also extended the concept of relativity from the reference system to the means of observation. Nevertheless, this account seems too one-sided. Fock's interpretation in reality resulted from attempts to creatively resolve the contradictions between Bohr's approach to quantum mechanics and the Marxist philosophy of dialectical materialism. So in a few words, Fock accepted complementarity, but he considered that Bohr diminished the role of quantum mechanics, leaving it only a symbolic meaning for mathematical formalism, and exaggerated the importance of the uncertainty relations. Fock considered that Bohr had overestimated the role of the measuring device in observational situation and underestimated the properties of atomic objects, properties given by the wave function. And this was somehow already present in substance in his introduction to the EPR debate. There he stated clearly that the dispute between Einstein and Bohr could be considered as a dispute about the physical meaning of the wave function. Fock actually saw dialectical materialism as a philosophy with valuable epistemological content. And he retained two main epistemological principles, scientific realism or materialism, and antireductionism. Fock's materialism manifested itself in his approach to mathematical formalism. For him, it was a direct reflection of material reality, and the physicist's duty was to extract, to reveal its physical significance. On the other hand, Fock's antireductionism consisted of understanding science as governed by a broad combination of theories whose field of application could not wholly overlap and which possessed their own conceptual apparatus. For Fock, the formulation of a physical theory had then to be accompanied by a strict evaluation of its scope as well as the various concepts used. In the case of quantum mechanics, Fock was determined to reveal the true nature of quantum phenomena, this as a materialist, and to accept their fundamental distinction from classical physics as an antireductionist. This is why he paid particular attention to the physical meaning of the wave function. He associated the concept of state, that the wave function described, with that of potential possibility. This potential possibility represents the probability of a quantum object as of having one or another behavior according to each possible external influences. The act of measurement transforms the potential possibilities for each physical quantities into a theta quantity. Probabilities were for him a real physical property of a physical system. As such, the wave function contains not only a description of the behavior of physical objects with respect to the means of measurement, but also of their properties. So that's it for Fock, but I also want to mention that his translation of the EPR debate triggered different reactions in Soviet Union. In particular, many people took seriously Einstein's suggestion that the statistical understanding of the theory would avoid conceptual difficulties. In that frame, the wave function will not describe the condition of one single system, but that of an ensemble of systems. So Alexander will certainly develop at length aspects related to such kind of interpretations. I just want to mention that in Soviet context, Konstantin Nikolsky was the first to work along these lines in 1936. But the ensemble interpretation was really embodied by Dmitry Blorintsev, who after World War II brought it to national and international recognition. And this approach, their approach, also defended compatibility with dialectical materialism. This was not the case of another actor, which also deserves to be mentioned, Leonid Mandelstam. His approach, called theory of indirect measurement, was an operationalist one. There was a very important focus in his work on the measurement process. Mandelstam's reception of the EPR debates was a mixed one. He agreed with Bohr on completeness, but could not accept a potential action at distance. When even though he rejected the EPR argument, he was seduced by Einstein's suggestion about statistics. And in developing his point of view, he was very much influenced by von Neumann, who was developing its axiomatic approach to quantum mechanics, which defended completeness and developed a mathematical language that was conducive to the analysis of statistical ensembles. But contrary to von Neumann, Mandelstam, like Nikolsky and Blorintsev, totally rejected that the theory describes individual processes. It can describe individual processes. So the Bohr-Einstein dispute transcended borders and was widely discussed by the Soviet physicists who developed divergent point of view. So so I could not enter into details, but overall on the subject of measurement, objectivity, causality, the different Soviet contributions were responding to questions raised and debated internationally. Nevertheless, it must also be emphasized by the official status of dialectical materialism as an essential component of state ideology in the USSR, also contributed to the establishment of a socio-political context which played an essential role in the emergence, diffusion, and reception of the different points of view. So with respect to quantum mechanics, an overview of this particular situation can be given by the dispute between Fock and Lorentsev in the early 50s. So Fock systematically opposed interpretations that defended the statistical approach to quantum phenomena. And concerning Lorentsev, his criticism was initially based on the physical and mathematical foundations of the ensemble approach, on their internal contradictions, but it was also accompanied in 1952 by lengthy considerations on contradictions with dialectical materialism. And it was exactly the ground on which Lorentsev in return built his response. The specific context of the Soviet Union in the early post-war period was then particularly conducive to such discussions. And we have already yesterday a very good presentation about that. So Andrei Danov, who developed this ideological doctrine which affirmed the division of the world into camps, and which initiated the most intense ideological campaign in the history of Soviet scholarship. So Mandelstam or Fock at that time were criticized for their positivistic tendencies, while Lorentsev was seen as an excellent response by the Soviet ideological authorities, and he received much attention. It is then important to underline that quantum theory was never in danger to be fully condemned in the USSR. But there was a definite increased ideological pressure when it comes to its interpretation. This notably explains why complementarity was often omitted in different works, textbooks, and public statements, and if mentioned, then only to be criticized. Fock, who had already been attacked by Mikulski at the end of the 30s, then adopted an original position towards ideological pressure. He understood that the defense of modern theories had to include a critical revision of some of their concepts in order to avoid a head-on collision with dialectical materialism. This is why he developed an explicit criticism of both. An article he published in 1951 not only explained for the first time the essence of his epistemological divergence with his Danish colleague, as I presented before, but he also condemned some of its positivistic features. Also, as far as complementarity was concerned, Fock avoided fully the term, except to criticize Bohr's tendency to apply it to other fields. So, as such, Fock was somehow building the necessary legitimacy for his frontal criticism of Lorentsev. So, the way ideological markers accompanied debates on the interpretation of quantum mechanics was a major characteristic of Soviet context. But after Stalin's death in 1953, the situation gradually normalized. Physicists won in autonomy and the ideological pressure faded. In 1958, there was a conference in Moscow on philosophical aspects of natural science. And it sealed a form of public consensus on the peaceful coexistence of different possible Marxist interpretations of quantum mechanics, including the view of Fock, which then clearly retained complementarity. So this is not necessarily what we expect from Soviet context to accept, but we can have different point of view which all agree with dialectical materialism. So Fock nevertheless still had to convince. This is connected to the last point I want to mention, the international reopening of the Soviet physics in the 50s. I will be brief since the episode is well known, but Fock had a dispute with Bohr in 1957 in Copenhagen, and this picture has actually been taken in Copenhagen, and thanks to the Niels Bohr archive, let me use it. But let me come back a bit earlier. The restart of international relations notably allowed the introduction into the USSR of the causal interpretation. The causal interpretation of David Bohm, of course. As a dialectical materialist himself, Bohm had received the support of various Marxist physicists in Western countries. In the Soviet Union, Yakov Terelsky, who had initially supported Lorentsev, gradually embraced the causal interpretation. In 1955, he edited the Russian translation of various articles by Bohm, and at the 1958 philosophy conference in Moscow, he clearly expressed his sympathy for the causal interpretation, first offering a new option within the spectrum, the Soviet spectrum of Marxist approaches to quantum mechanics. Once again, Fock objected to this approach, along with his pupil, Yuri Nemkov, and remarkably, actually their voice reached the French debates about causal interpretation, which were quite strong in the 50s too. And in this sense, Fock was joining Rosenfeld, who, as a faithful right-hand man of Bohr, led from Copenhagen a real fight against causal interpretation. So, after Fock's criticism of Bohr in 1951, their common stance against Bohm offered a possibility for a compromise. And this potential compromise was certainly discussed in Copenhagen. I think it is interesting to underline that Fock was invited in Copenhagen not for his work in quantum theory, but to give talks on general relativity by Christian Moltmann. But at some point, the main event would become his lively discussion with Bohr. So Fock exposed his disagreement, his epistemological disagreement with Bohr, and he also explains the ideological grievance held against Bohr in the Soviet Union. There is no clear account of what Bohr thought of all of this, but interestingly, at least for Fock, a year later he published an article, Bohr published an article which clarified his position towards causality and praised the objective character of complementarity. So Fock perceived it as a direct response to his criticism, and even an acceptance of his criticism. And he started using this episode to publicly strengthen his defense of complementarity and to favor the diffusion of Bohr's idea in Soviet context. So in 1961, Atomic Physics and Human Knowledge was published in Russian, and in 1962, Bohr visited Soviet Union. Russia actually went to Moscow. So from this point on, Fock's slightly independent approach to quantum mechanics became the main reference in the USSR and was praised for its ability to free the Copenhagen interpretation from inclinations toward positivism. Fock never ceased until he died in 1974 to fine-tune and defend his approach to quantum mechanics. But this is where our story ends for today. My conclusion will be rather brief, notably because I suspect I could be overlapping a bit with Alexei's talk. I just want to give you an appetizer. On Saturday night, it's a good time for an appetizer, I think. So let me put just 3 words on the screen. So these values, that you certainly all recognize as mirroring Paul Forman's values attributed to famous physics in the 20s, were not necessarily those of Fock. But through his contribution, his trajectory, and the dispute he was involved in, we could actually observe how influential they were in the Soviet context. There, a different distribution of ideological preferences was at the basis of the physicist's approach to quantum mechanics. They accompanied their intellectual trajectories and structured their scientific disputes. all of this in a unique political and ideological environment. And as a final word, a bit provocative but on purpose, I then just want to underline that what was the greatest weakness of this milieu, its authoritarian character, also revealed from a purely non-humanistic and detached point of view, a strength. It forced Soviet physicists to thoroughly examine the established truth and to look for alternatives, to widen the spectrum of possibilities. As such, they contributed significantly through the 20th century to the debates for a better understanding of quantum mechanics. Thank you for your time.
I have some time for questions. Yes, here. Yes, we have time. It's very interesting. I was wondering, so, I've heard before about the foundations in Soviet Union, and of course Fock is always the protagonist in this story, and Lotinska also is mentioned several times, but not many more names. So I was wondering, so in the Western case, we know the shut up and calculate culture that prevented most of the field system was a very narrow field that was almost carried out in an underground culture. What was the general acceptance? Because there is just a few names that always appear that basically we're just trying to see what interpretations in the spectrum of interpretations are possible to be compatible with a dialectical interpretation. But was it widespread? Because Landau, for instance, detached himself from the interpretation of debate.
And
so
he has many reasons.
okay.
I mean, that's the point. Most of them didn't want to,
Yeah.
because they knew what it could lead to.
Okay.
But sometimes, at some point when it was really necessary to act as a group against the ideology of the philosopher of the party, they could find solutions to defend mostly interpretation as a group, and there are many reunions, many meetings to organize conferences where Tam or Frankel would also participate in the discussion, but of course they would never publish about that.
But the interpretations were not dismissed as non-physical or nonsensical in the Soviet Union, or well, of course they were bound to be in a certain area.
Yeah,
they were not free, but as a general philosophical problem, they were not like dismissed as well in the same way they were in the West. I'm asking,
dismissed. You mean like complementarity would be dismissed in the early 50s?
I mean in the same way that in the post-war era in the Western countries, in the US in particular, it was not possible to talk about interpretations in physics circles. It was like just not, it was a taboo topic.
Okay.
Was it the same in Soviet Union is my question.
They were somewhat forced to give their opinion.
Okay.
When they could, they would avoid it.
Okay.
But
So they were careful, but not.
Different situation.
Okay, thank you.
We've got Wayne.
When I read Soviet physicists avowing dialectical materialism and reassuring the readers that what they're saying is in accord with dialectical materialism, I often wonder to what extent is this due to an actual commitment to dialectical materialism, and to what extent is this being said purely for political reasons. Do you have any thoughts on that?
Depends on who we are talking
Like,
about. So
can you tell? Like, are there sometimes clues in somebody's writings what their actual attitudes are?
for Fock, it's sincere adherence.
Okay.
Lohintsev also. When those who are really engaged, yeah. The other one, it's just put some aphorism from the English.
I remember as an undergraduate seeing Random Lifshitz textbooks, and they always have the beginning. This, the content of this is in
As such,
accord with
doesn't
dialectical
mean anything.
materialism.
It
just have time for a last question from Simon.
Yeah, just a quick question about Everett. Was there any interest, anyone looking at Everett's work in the 60s after DeWitt in particular, in the 70s? No.
Actually, it looks like after Stalin's death, there was a big relief, and nobody wanted anymore to position because, okay, let's just do physics and not anymore interpretation.
Shut up and calculate.
I don't know. Do you agree? I'll say it was shut up and calculated.
Well, for Landau,
Yeah.
or rather, I mean, he drew a line, and certainly relations it's fine because it's mathematics. Complementarity is just blah blah blah, and
Yeah.
that's so
Yeah.
you need to get it out. And like the materialism is also just empty words. So basically, he rejected both complementarity and dialectical materialism. He avoided talking about that.
Okay. On that, we should thank Jean-Philippe Martinez.